What if I told you a tiny stream of water could make real electricity? Not fake electricity, not maybe if you imagine it hard enough electricity. I mean actual power for moving water, using a build that cost me about $15. And if that sounds too good to be true, that's exactly why I wanted to test it. Because people hear free electricity and immediately think one of two things. Either it's genius or it's complete nonsense. So today, I'm building a mini water turbine from cheap parts to answer one simple question. Can flowing water actually generate usable power at home? And I'm not talking about powering a whole house. I'm talking about real proof, a real turbine, real spinning blades, real current. And if this works, we should be able to light something up using nothing but water. So here's the plan. I've got a small DC motor, some simple blades, basic wiring, and a water source. That's it. No giant dam, no expensive generator, no advanced engineering lab, just a cheap DIY setup that should, in theory, turn water flow into rotational motion and rotational motion into electricity. If it works, it's one of the coolest little science builds you can make. If it fails, we'll know exactly why. And honestly, that's what makes this fun, because this is right on the edge between this might actually be brilliant, and this is about to do absolutely nothing. So first, let's build the turbine. The heart of this whole setup is the motor. Most people think of a motor as something that uses electricity to create movement, but it also works in reverse. If you spin the shaft fast enough, it can generate electricity. That means the motor becomes our tiny generator. Now the only job left is getting water to spin it. For the blades, I'm using cheap, lightweight pieces shaped to catch the flow of water. Nothing fancy. The goal is simple. The more efficiently the blades grab the water, the faster the motor spins. And the faster it spins, the more power we should get. So I'm attaching the blades carefully around the hub, spacing them evenly so the wheel stays balanced. Because one thing that kills projects like this fast is wobble. If the wheel shakes or drags, you lose speed. And with a build this small, speed is everything. Already, this is the part I like most about projects like this. It looks simple, but every little detail matters. Blade angle matters. Weight matters. Friction matters. Water direction matters. A tiny mistake here can be the difference between free electricity and wet disappointment. The wheel is on, the motor is mounted, the wiring is connected. And on the other end, I've got a small LED ready for the first test. That's the moment of truth right there. Because if this thing can light an LED, even for a second, that means it worked. Water turned the blades spun the motor, and the motor generated electricity. That's the chain. Cheap parts, real power. So I line it up under the water flow, adjust the angle, make sure the wheel can spin freely, and here we go. Water on. The blades move a little at first, then faster, then suddenly the whole wheel starts spinning. And right away, I'm watching the LED. Nothing yet. The turbine is spinning, but not enough. That's the first reality check. This is exactly where weak DIY builds fall apart. Something moves, so it looks promising, but movement alone doesn't mean useful power. The motor needs enough speed to generate enough voltage. If the water pressure is too low, or the blades aren't catching enough flow, the system looks alive, but does nothing. So instead of pretending it worked, I'm adjusting it. I change the angle of the water to hit the blades more directly. I bring the flow tighter into the wheel. I reduce some drag. Then I try again. Water on. This time the wheel spins harder. You can hear it. It's smoother, faster, more stable. And then, there it is. A tiny flash from the LED. That one little blink tells us everything. This actually works. Now it's not bright yet. It's not stable yet. But that flash means the concept is real. Water is generating electricity. Not enough to brag about yet, but enough to prove we're not crazy. So now the challenge becomes, can we make it better? And this is where the project gets a lot more interesting. Because once you know something works a little, you immediately want to know how far it can go. I increase the water flow. The wheel speeds up again, the LED flickers, then glows more consistently. And that is such a satisfying moment because now we've crossed the line from science fair idea to actual result. It's small scale, but it's real. A cheap motor, a homemade wheel, and flowing water are now producing visible electrical output. That's the first payoff. But I wanted to push this further, so I start testing what actually changes the output. First, blade angle. If the blades are too flat, water slips off. Too steep, and they resist the flow instead of using it. There's a sweet spot where the water strikes, pushes, and exits cleanly. Once I tweak that, the spin gets noticeably better. Second, alignment. If the water hits too high or too low on the wheel, you lose force. But when it hits the blades right where they can pull the most rotation, the difference is immediate. Third, stability. A shaky turbine wastes energy. Once the wheel runs smoother, the output becomes more consistent. And that's the second big lesson here. These little systems are brutally honest. They don't care about hype. They only care about efficiency. If your design is sloppy, the results expose it instantly. Now with the improved setup in place, I run it again. The wheel spins fast. The LED lights up faster this time, brighter too. And now you can actually look at it and say, okay, that is electricity from water, not from a battery, not from a hidden source, from the water spinning the generator. That's the moment people wait for in videos like this, the point where the theory becomes visible. Because until the light comes on, it's just a craft project. Once the light comes on, it becomes proof. And this is exactly why water power is so fascinating. On a giant scale, it runs entire regions. On a tiny scale, it still follows the same principle. Moving water carries energy. Capture that motion correctly, and you can turn it into something useful. Now let's keep it real for a second. Can this power your house? No. Can this replace your electric company? Definitely not. Can this run heavy appliances? Not even close. But that doesn't make it useless, because that's not the point of this build. The point is to prove the principle in the simplest, cheapest, most visual way possible. And in that sense, this is a huge win. For $15, we built a mini turbine that generates real electricity from flowing water. That's amazing. It also opens the door to better versions. A stronger motor, better blades, better flow control, a more efficient wheel, a bridge rectifier, a charging circuit, a small battery bank. Once the basic idea works, now you can scale it, refine it, optimize it. And that's where simple projects stop being toys and start becoming engineering. So before I end this, I want one more clean test. No adjustments, no excuses, just the final build running the way it was meant to run. Water on. The blades catch immediately, the wheel spins clean and fast, and the LED lights up. Steady. That's it. That's the result. A cheap mini water turbine making real electricity from flowing water. And the best part is, this build forces you to see energy differently. Water doesn't just flow, it carries motion. Motion can become rotation. Rotation can become electricity. Once you see that happen with your own eyes, even on a tiny scale, it changes the way you think about power. Because this didn't come from some giant machine. It came from a small idea built with cheap parts and a little curiosity. So yes, water can generate electricity, even in a tiny DIY setup like this. The real question now is, how much better can we make it? Do we build a stronger version next? Test different blade designs? Try charging a battery? Or see if we can power something bigger than an LED? Because now that we know it works, I kind of want to keep going.